Welcome to A-Level Physics at King Edward VI Grammar School. Thank you very much for taking the time to watch this presentation. We hope very much that you come and study with us next year, and I hope that this video will give you an insight into the subject areas we study at A-Level. At King Edward VI, we teach A-Level Physics using the AQA specification. We teach this because it covers a broad spectrum of really interesting physics, and we feel it provides our students with the best opportunity to achieve really high grades. The qualifications are linear. That means that the students sit all of the exams at the end of their A-Level course. So what does the specification look like? Well, in year 12, it is split into 4 sections. In section 1, we find out about fundamental particles, what protons are made of, and how particles interact, and what holds the nucleus together. In section 2, waves and optics, we find out about the properties that apply to all waves, including refraction, diffraction, interference, and how to create stationary waves, which you will see some year 13 pupils demonstrate later in this presentation. In section 3, you look at the principles and applications of mechanics and materials. This topic underpins many areas, including engineering, transportation, projectiles, and things like nanotechnology. In the electricity section, you build on what you learned in year 11. You will look at materials such as semiconductors and topics such as superconductivity. In year 13, section 6 develops the work done in year 1 between force and acceleration in the context of objects in circular motion at constant speeds and objects oscillating in simple harmonic motion. Additionally, you will study the thermal properties of materials, including the relationship between energy, temperature, and physical state. In section 7, you will deepen your understanding of the gravitational force, electrostatic force, and the forces that magnetic fields can exert on current-carrying conductors and moving charges. Section 8 will extend your studies on the structure of the atom and mechanics. You will consider the properties of alpha, beta, and gamma radiation and experimentally verify the inverse square law for gamma radiation. Chapter 9 looks at wave-particle duality, the photon theory of light, and Einstein's theory of special relativity and its implications in relation to our understanding of the link between space and time and the link between mass and energy. Sections 5 and 10 are embedded throughout the course, and they relate to practical skills, which we'll talk about in a bit more detail now. There are 12 required practicals that students carry out in order to achieve endorsement for the common practical assessment criteria. And we've been very fortunate at KEVIX in that no one has ever not received endorsement for that section of the course. Universities really like students to achieve this. A-level physics is a practical subject, and we carry out many experiments and practical work throughout the course to reinforce understanding and student learning. We have a very well-stocked physics prep room and our own specialized technician. Why should you choose A-level physics? Well, A-level physics gives you the opportunity to explore phenomena of the universe, and the doors it opens are just as vast. In terms of further education or future careers, A-level physics opens many doors in, for example, physics, astrophysics, biophysics, the other sciences, medicine, engineering, finance, or even architecture. The list goes on, so having an A-level in physics definitely doesn't limit options, but increases them. 3 written examinations take place at the end of the course. Each are 2 hours long. Paper 1 focuses on the work in Year 1 or AS level. Paper 2 focuses on the work in the second year of the course. And Paper 3 focuses on practical skills and the optional unit Turning Points in Physics. Do you need to take A-level maths to do A-level physics? Well, it's not a requirement that you need to do A-level maths, although it is really helpful as many of the topics overlap. However, provided you have a good grade in GCSE maths, say a 6 or above, and are confident in rearranging equations, then that would be fine. In terms of pupils who did GCSE combined science, that is fine also, provided you have scored a 6 or better in the physics section. KEVI is an Ogden Hub school, and we coordinate events for the 5 schools within our partnership. This gives us access to increased funding and the chances to participate in lots of events across the hub. These events include Key Stage 5 workshops and also workshops for other year groups that Key Stage 5 students help to organise and run. And this is a really good way for them to develop not only as scientists, but as organisers. If you have any further questions, please don't hesitate to email me and I'll endeavour to get back to you as soon as I can. What will follow now is a short video from some of the Year 13 physics students demonstrating them carrying out a practical.
Hello there, welcome to the KEVI's Physics department. Let me show you around. To my left is the prep room, and that's where we keep the equipment for many of our practicals. In front of me is one of the specialist physics laboratories. And just through this door is another laboratory full of sixth formers doing a string oscillator practical.
One of my favourite topics in physics is the waves and optics topic, which explores the mechanics of waves in greater detail.
The reason I chose to study physics is because not only did I enjoy it at GCSE, you can also learn lots of transferable skills and the teachers are very passionate.
So, that's the physics department. Thank you for coming to look round. We'll see you soon.
So thank you very much for taking the time to watch that video. I hope to see you soon. Take care.